Morning everyone, we're here at Maker's Machining taking a look at a non-standard machining operation that we're doing. As you can see, we've got a big long bar in the milling machine here. It's about 52 inches long if I'm not mistaken, and we're setting it up here. We've got some cuts we have to make on it. This bar has already been machined. It's made out of I believe S7 tool steel, shock resisting steel. It's a pair of bars, and what they're used for is the rails on a press where the die slides back and forth and travels with the product when it makes a cut. So these are hardened rails that support that die. The die that sits on there has grease grooves and wear plates and bronze wear plates and everything. But you can see here, it's a nice smooth surface. It's been surface ground. This started out as a bar of material that was probably quarter of an inch bigger per dimension, and we machined it, put the holes in there. The back side of it has some keyways in there. You want to flip that one over, Richie, so I can kind of pan over to show them the keyways there. We've got a pair of these rails here, and we've machined keyways, hard milled them in the bar to locate them on the press. The press that these go on have key slots milled into them, and then for making replacement rails, since these rails are so long and skinny, they warp when you heat treat them. They get heat treated, or they get heated up to about 1800 degrees, and they get quenched. And then after that, then you have to grind them and get them flat, parallel, square, so there's no misalignment. They got to be perfectly parallel and true. So after they get ground, then we bring them back here and we'll finish our screw holes. We got a chamfer in there. The keyways are all machined. You can see the chips are blue because it's been machined as a hard material. So you get your carbide cutter in there and it gives you a nice blue chip. But anyhow, it's got to be dead straight and true, and then you couldn't put the keyways in ahead of time or even rough them in because they won't stay in position. So we hard mill those keyways in afterwards. We got countersunk holes for the bolts that hold it down. We'll go back over here by the machine. Even the holes were put in ahead of time, but they move. So I think we moved from the center of the bar to the outside ends. It grew about a 1/16 of an inch per side, if I'm not mistaken, maybe a little bit less. So we had to, after the heat treating and grinding, we brought them in here. We're cutting a bevel on the edge here now. So the machine or the die that slides back and forth on there, we don't want a sharp corner there. Even all the holes here, we've hard milled a chamfer on those. So having the setup here, these take 8 setups here to do the work. You know, we machine the bottom side, get it flat, put the holes in. We got to slide it from one end of the machine to the other, and you can see that we've got the indicator up here in the spindle of the mill. So we can travel. What's our travel on this thing here? 51 inches, 50 inches. But the bar is, I believe it's 67 inches if I'm not mistaken. I was wrong on the first comment there. Anyhow, so you can machine part of it. Our machine is dead true and accurate, so if we can machine about 2/3 of the length that we need, then we can slide it down, pick up on the straight edge that we had, and finish our work. So it's just a typical day in a machine shop where you've got to figure out how to do your work on your part and make it true and accurate. So here we've got a Herco mill. It's got all the tools in it. All of our controls and stuff have graphics in there that as we do more complex cuts, we're able to get the parts machined. But anyhow, it's knowing how to set the part up in the machine so it gives you a good quality part. That's the bottom line. Anyhow, just thought I'd put this out there for you to look at. We'll talk to you again sometime. So long.